Hi there, welcome to another video about Math SL paper, particularly about May 2025. Paper 1. Is the paper difficult or easy? We shall discuss it soon, but just a reminder, for paper 1 you need to get used to the formula booklet because it will be helpful for you. Okay, so let's start with section A. Before we do, please note that this video was made before the official mark scheme was published, so it is recommended that you try to solve the questions too. Number 1. Write each of the following expression in the form learn k, where k is an element of z plus, that means positive integer. To solve these questions, you must know law of logarithms, which are available in the formula booklet. For example, for question A, you can use this formula. For question B and C, you can actually use this formula. Okay, let's begin. For 1A, learn 3 plus learn 4, that's equal to learn 3 multiplied by 4. That's equal to learn 12. And 1B, we have 3 learn 2, that's equal to, we bring this 3 back to here, that become learn 2 to the power of 3, which is equal to learn 8. For C, negative learn 1 over 2 is the same to minus 1 times learn 1 over 2. So we can bring minus 1 back to here. So we have learn 1 over 2 to the power of minus 1, which is equal to learn 1 over 1 over 2, which is equal to learn 2. Okay. In case you're wondering how to get from 1 over half to 2, I put some note over here. Okay. Number 2, consider the function f of x is equal to 4x cubed over 3 subtracted by 16x, where x is an element of real numbers. The graph of y is equal to f of x has a local minimum point at pq, where p is greater than 0. Find the value of p and the value of q. Well, I hope you know by now that to find a local minimum point, what you do is differentiate the given function and equate to 0. Let's check the formula booklet. Here we go. So we can use this derivative formula. Yeah, this is the power rule to differentiate the given function. Right. So again, we differentiate f of x and equate to 0. What we do, we bring this power here to the front. So we have 3 multiplied by 4 over 3 multiplied by x, and then we subtract the power by 1. And then the derivative of 16x is just 16, and equate this to 0. And then 3 times 4 over 3 is just 4. So we have 4x squared subtracted by 16 is equal to 0. And then we add both sides by 16 to get this equation. And then we divide both sides by 4 to get this equation. And then we apply square root. Yeah. Therefore, x is equal to plus or minus square root of 4. But here, p, which is the x coordinate, must be greater than 0. So we ignore the negative 2 and we only use x is equal to positive 2. So p is equal to 2. To find q, what we do is we substitute x is equal to 2 into the original function like so. Okay, and then we calculate to get Q, which is equal to f of 2, which is equal to the y coordinate. Yeah, that's equal to negative 64/3. And there you go. P is equal to 2 and Q is equal to negative 64/3. Next, question 3. Bob invests 1,000 dinar in an account which pays a nominal annual interest rate of 4%, compounded quarterly. The amount of money in the account after one complete year can be written as 1,000 multiplied by 1 plus k all to the power of 4. And Q is a rational numbers. How to solve this question? Let's begin by looking for relevant formulae that we can use from the formula booklet. And yes, we can use this compound interest formula. Okay, for question A, write down the value of k, that k there. Notice this is similar to this. Yeah, PV present value, that is 1,000, and then we have 1 plus r over 100, or r percent, divided by k. Okay, let's try to answer that. So there you go. Yeah, so we have the interest rate 4% divided by 4. Yeah, because the money is compounded quarterly. That's equal to 1%. Therefore, k is equal to 0.01. Yeah. Next, the questions asks to expand and simplify 1 plus x all to the power of 4. And here is the relevant formula. Yeah. So you are required to do this binomial expansion. Yeah. So you can use this formula here. Okay, let's do it. So we have 1 plus x all to the power of 4, that's equal to, see this? This is power of 4, meaning there should be 4 plus 1 number of terms. So we have 1, 2, 3, 4, 5 terms. Yeah. And if we consider 1 as the first element and x is the second element, then we can assign this given power 4 to the first element. Okay, so we have 1 to the power of 4. And then we can assign 0 to the second element, x. So we have x to the power of 0. If we look at this power here, power of 4, this power decreases as we move to the right. So we have power of 4, 3, 2, 1, 0. And for this power 0, this increases as we go to the right. So we have 0, 1, 2, 3, 4. And the total power for each term is equal to the given power 4. But we are missing the coefficient. See this given formula? It has coefficient, and choose one. Yeah. Well, since this is a non-calculator paper, I will use Pascal triangle like so. This is the format. Yeah, so we have a plus b all to the power of n, and the power n here is obviously 4. Yeah, so we use this, n is equal to 4, and here are the coefficient 1, 4, 6, 4, 1, and let's put these, yeah, into this expansion like so. All right, so we have 1, 4, 6, 4, 1, and then we'll simplify. So there you go. That's the answer for number 3B. Okay. Next, for question C, hence or otherwise find the amount of money in the account after one complete year, giving your answer correct to the nearest dinars. Yeah, So that's important there, to the nearest dinar. Right, so we're using this formula, knowing that k is equal to 0.01, and also we're going to use this expansion because the questions say hence, yeah, or otherwise, yeah, but in this case I use hence because I can use this previous result. So I have here 1 plus x all to the power of 4 expansion equal to this, and x in this case is equal to 0.01. So I can substitute x is equal to 0.01 to here, like so. Okay, so replace x with 0.01, and then go to the next line. We have 1 plus, well, 4 by 0.01 is equal to 0.04, and then 0.01 square is equal to 0.0001 multiplied by 6, and so on. Here I only choose these 1, 2, 3 terms, okay, and multiply by 1000 based on this formula. Okay, why? Because again the questions say give your answer correct to the nearest dinar. So here we'll multiply by 1000. If you look at this term, for example, okay, if you multiply this by 1000, this will not be rounded up. Therefore, these two terms can be considered insignificant. So there you go. The answer is 1040.6 rounded up to 1041 dinar. Number 4, find the area completely enclosed by the curve y is equal to e to the x, y is equal to negative e to the x, and the lines x equal to negative 1 and x is equal to 1. To solve this question, you need to know the shape of an exponential function. Here is the sketch of the curve of y is equal to e to the x. The curve passes through point 0, 1. And this is the sketch of y is equal to negative e to the x. And this negative notation means reflection of y is equal to e to the x along the x-axis. So this is actually the graphs that we are dealing with, and we want to find the area bounded by the two curves, and x equal to negative 1 and x is equal to 1. What we can do, we can calculate this area here. Yeah. The area bounded by the curve, this curve here, and the x-axis from -1 to 1, like so, and we multiply by 2 because there are two sections there. Okay, so again the area is equal to 2 multiplied by the integral. Because we are finding area, so we use integral from negative 1 to 1 of e to the x with respect to x. The integral of e to the x is just e to the x. You can find this in the formula booklet, and we put the lower boundary and the upper boundary. Okay, we substitute 1 to here, it becomes e to the 1 subtracted by, then we substitute the lower limit negative 1 into here, so we have e to the power of negative 1. Okay, and then we simplify. So there you go, that's the answer. Next, number 5, consider events A and B such that probability of A complement is equal to probability of A union B is equal to 3 over 4, and probability of B given A is equal to 2 over 3. Find probability of A intersection B and show that events A and B are independent. Right, so here is the formulae that you can use, and these are available in the formula booklet. Yeah, so again, you must know where to find the formula or formulae in the formula booklet. To solve question A, let's work based on the information given. We are given probability of B given A, and PB given A is equal to, using this formula here, is equal to PB intersection A over PA, and PB intersection A is just the same as PA intersection B. We know probability of B given A, which is 2 over 3. Okay, so we rearrange this to become 2 over 3 probability of A is equal to probability of A intersection B. Let's call this equation M. Next, this is a key formula in this question. Okay, we should know that probability of event A plus probability of event A complement is equal to 1. We know probability of A complement, that's equal to 3 over 4. Therefore, probability of A is equal to 1 minus 3 over 4. So probability of A is equal to 1 over 4. This can then be substituted into equation M, okay, this one here, to find probability of A intersection B, like so. So there you go. That's the answer for question A. For section B, show that events A and B are independent. Then we can use this formula. We know probability of A intersection B, this one here, and we know probability of A from here, but we don't know PB. Then how do we find PB? Then we use this formula. Yeah, formula for combined event. So let's have a look. Okay, right, this is the formula for a combined event to help us find PB. So we substitute PA union B, this is given up here, 3 over 4. That's equal to PA is 1 over 4, the one that we calculate before here. Okay, plus PB, we don't know yet, subtracted by PA intersection B. There you go. Okay, calculate PB. Yep, so probability of B is equal to 2 over 3, and then we can substitute to equation N here, like so. Okay, so again, probability of A intersection B is equal to 1 over 6, is equal to probability of A is 1 over 4, multiplied by probability of B, this one here, 2 over 3. So the left hand side is equal to the right hand side, therefore events A and B are independent. And finally, the last number for section A. Consider a sequence of 10 rectangular picture frames, F1, F2, etc., F9, F10. Picture frame F1 has width 4 centimeters and height 5 centimeters. The width and height of picture frame Fn are each increased by 50% to generate the width and the height of the next picture frame, Fn plus 1, for n is an element of positive integer, and 1 is less than or equal to n, and n is less than or equal to 9. Question A, part 1. Show that the area of picture frame Fn is equal to 20 by 9 over 4 to the power of n minus 1 centimeter square. This is quite a long question for section A, but then again, please don't forget we have our formula booklet to help us. Notice this information here, increased by 50% for both the width and the height. Yeah, and this format also tells us that this is a geometric sequence. Yeah, see this format here? Okay, they are of the same format. Let's start with the information given. Okay, we are given the width is equal to 4 centimeters, this one here, and the height is equal to 5 centimeters. Then we can find area number 1. Yeah, 4 by 5 is equal to 20 centimeters square. What about the next areas? Well, the question says the height is increased by 50% and the width is increased by 50%, and this will also affect the area. Let's see. Let's find height number 2. That's equal to 5, the initial height given here, plus 5 times 50%. That gives us 15/2 centimeters for height number 2. And likewise for the width number 2 is equal to the initial width, 4 centimeters plus 4 by 50%, and that gives us 6 centimeters. And then we can find area 2, that's equal to height 2 multiplied by width 2, that's equal to 45 centimeters square. And using similar method, we can find, or we can calculate height number 3 and width number 3. And we can also calculate area number 3. From these two areas, we can also calculate the common ratio, because we know that the sequence resembles a geometric sequence, and a geometric sequence must have a common ratio. So common ratio equal to area 3 over area 2. So substitute area 3 into the numerator and area 2 into the denominator and simplify to get 9/4. That's the common ratio. And then using this formula for the general term of a geometric sequence, UN in this case is AN, area N, or I should have used FN, yeah, sorry for that. That's equal to initial area 20 multiplied by the common ratio 9/4 to the power of n minus 1. So there you go. That's the answer for question A, part 1. For question number 6A, part 2, it says, hence find the mean area of the 10 picture frames, giving your answers in this form. Well, to find the mean, we need to find the total number of the areas or picture frames in this case divided by 10, and the sum of all of these resemble geometric series, and this is the formula to find the sum of the first 10 areas, or the sum of the first 10 rectangular picture frames. We know the initial area, that's 20. We know the common ratio here. Okay, the calculation is also shown in the previous part. Okay, n, that is 10 subtracted by 1 over 9/4 subtracted by 1, and simplify the answer to get this expression there. So the mean is equal to this, the sum of the first 10 areas or rectangular picture frames divided by 10, and that can be simplified into this expression. Therefore, P is equal to 8/5, which is a positive rational number, and A, that A there, that's equal to 10, which is a positive integer. Next, question 6B, find the median area of the 10 picture frames, giving your answer in this form. Well, the median is equal to the average of the two middle areas, which are area 5 plus area 6, and that's equal to 20 multiplied by 9 over 4. We're using this formula, by the way, to the power of 5 minus 1, plus 20 by 9 over 4 to the power of 6 minus 1. Simplify this into the required form. So Q is equal to 130 over 4. So there you go. I hope this video helps. Thank you.